Okay, number 2. This one was sneakily a concepts question and not a math question. So we've got a rock, we throw it in the air. When it's at its maximum height, we're wondering what the speed is. Okay, at maximum height, that means, so we were here above the horizontal. Wait, that's not right. 53 degrees. And then we go woo, and then we go here. 10 meters per second. Okay, well, it's speed in the y direction, going like up and down. That's 0. But it still has horizontal velocity that is not 0. I think the answer key is wrong. I think. So going this way, so we have our like initial velocity in the x direction and we have velocity in the y direction. I agree that that's the velocity in the y direction, but not the x. Okay. Oh, this just got interesting. Okay, so the x direction velocity, that is 10 times the cosine of 53, because that's adjacent. Make sure you're in degrees, not radians. Cosine of 53 is gross. Multiply that by 10, 6.01. Oh, that rounds up, 6.02 meters per second. And since there's no acceleration in the x direction, like you can't keep pushing it once you've let go. So the initial velocity and the final velocity and the velocity the whole time on the x direction is 6.02 meters per second. I would say that this is the right answer, right? Your initial, your velocity at the peak here, the y velocity is 0, but the x velocity is 6.02. What is it asking? It's thrown, it has a speed, top of the building, air resistance can be neglected. What does that change? Yeah, there's definitely no acceleration in the x direction. If there's air resistance, that means there's like friction in the air that can slow us down. So it might be like less than 6.02, but since air resistance is neglected, it's 6.02. Yeah, that's not right.